Sir, so this morning I'm going to discuss about the pressure. So this is to be continued from problem number 1, 2, and 3. So this one is problem number 4 and 5 are combined. So now uh, I'm going to discuss about the two problems here. So with solution. So now a diver is currently loaded. This one is problem number 4, sample number 4. So now a diver is currently located at a depth of 500 meter in the ocean. So in letter A, question is what is the gauge pressure at this point. So now in this problem, so the required here is the pressure gauge at this point. So what is the pressure of this point? So now let's say we have an example here. If we say this diagram, so example, this is sea level. So this one is the diver. So we are going to how to find the pressure of that level. So now we need to understand that the gauge pressure is the pressure due to the flow to the water alone. So the absolute pressure is going to be the total pressure due to the weight of the water above. So now let's find to find the pressure gauge inside this. So we are going to use this equation. So Pg equals to Fa equals mg over A. So Pg or Pg equals to Fa equals to mg over A. So or Pg, pressure gauge, equals to pressure, volume, gravity over area, or equals P A Hg. So we are going to cancel this one, A and A. So this one is example. Here is the cylinder, then V equals to A, then B equals to pi r squared times height. So this one example. So now to find the pressure gauge, so we use this last equation. So Pg equals to Pgh. So here is our value of our pressure. So 100 here, 1025 kg meter over per meter cube. So here is our value of our pressure. So this is 9.8, the constant of our atmospheric in the sea level. This is the gravity acceleration, the constant of our gravity acceleration, 9.8. So and then here is our 50 this 50 meters height from our depth from the surface of the sea and going to the ground. So this going to this point. So now to get the pressure gauge of that point, so what we are going to do is to multiply so the pressure and gravitational acceleration constant, and then times 50 is, and then the answer is 502. Let's try to calculate. So 1000 25 times 9.8 times 50. So now we have a 5,002 and 250. So Pascal. So what we are going to do here, because this is Pascal, see, we are going to divide into 1,000 Pascal to become a kilopascal. So we are going to divide. So this is the answer. The pressure gauge is 502 kilopascal. So that's the pressure gauge, 502 kilopascal due to the water above the diver. So the next problem is problem number 5. Same question but the same answer, but same problem but different question. So here is our question number 2. What is the absolute pressure? The density of the sea water is 1,025 kilogram per meter cube. So now we are going to solve this problem with solution. So the total pressure is equals this equation. We are going to use this equation. The total pressure is equals to pressure gauge plus atmospheric pressure. So now we are going to write down here the value of the pressure gauge is 500.25 kilopascal plus 101.3, because this is our absolute value of our atmospheric pressure, 103. So kilo kPa. So now our answer, now we're going to plus this. Our answer is the total pressure is the total pressure is 603.55 kPa. So that's the absolute pressure that in this point here. So this point we have the total pressure of 603.55 kPa, kilopascal. So that's all, sir, and thank you.